So welcome again. Please write down in the chat box if you can hear my voice clearly and see my screen. Okay, thank you. So let me start our second day of 2 days workshop on GIS application in hydrology using SuperMap. This is our second day for our 2 days training session, and we are here from the SuperMap team. SuperMap technical support engineer from SuperMap Asia and Oceania Center, and we are collaborated with the CIRS, North South University, and the Kathmandu University of Nepal. Warmly welcome all of you in our today's training session. Today is the second day of our 2 days training session on GIS application in hydrology using SuperMap. In our last day, we demonstrated functions of SuperMap iDesktop X, and we showed the basic functionalities and also uh, the interfaces of SuperMap iDesktop. And we demonstrated some functionalities to run or import the dataset, how to download the digital elevation model, and also how to import them, how to clip them, and also the exporting functionalities of SuperMap IDEX X. And we also showed you the mapping functionalities of SuperMap IDEX X, the 2D and 3D visualization of dataset in SuperMap IDEX X, and also we have shown you the possibilities of doing such analysis and also uses of the toolsets stored in SuperMap iDesktop that you can explore it by yourself. So in our today's session, I'm here. Mr. Obaidur Rahman, Technical Support Engineer, SuperMap Asia and Oceania Center. So I will demonstrate today that these functionalities, and also we'll go forward using such or following such chronology. Like first of all, we will show you how what are the basics of hydrology and how can we use the GIS in this sector, and then we will go for like field sync, calculating flow direction, calculating flow length, calculating flow accumulation, calculating pour point in SuperMap IDEX X. We will show you how to demarcate the watershed in SuperMap IDEX X, and the basin demarcation, the extraction of river water system, river classification, vectorization, connect water system, map making, and finally, we will show you how we can use the layout in our SuperMap iDesktop. And for today's session, we will both demonstrate in SuperMap iDesktop X and also SuperMap iDesktop. So first of all, I would like to introduce you like hydrology analysis overview. So SuperMap iDesktop has the toolset of hydrology analyst. Actually, hydrological analysis is based on a digital elevation model, which is actually raster data. Okay, let me check. Okay. So hydrological analysis is based on a digital elevation model, which is a raster data to establish a water system model, which is used to study the hydrological characteristics and simulation of surface hydrological process and make a forecast for the surface hydrological situation in the future. The hydrological analysis model can help us to analyze the scope of flood, the position of the runoff pollution sources, and also we can predict the geomorphological changes on runoff. And it is widely used in regional planning, agriculture, forestry, disaster prediction, road design, and many other industries and fields. So, in this perspective, we can summarize that the hydrological analysis using SuperMap iDesktop or using GIS application is more important in our planning analysis, in our city planning, in our infrastructure development, and also our agricultural development, forestry, disaster prediction, natural resource management, etc. So here, the hydrology analysis overview. There are some basic concepts like water system, basin, sub-basin, watershed, catchment point, etc. So hydrology analysis overview showing that the hydrology is based on digital elevation model. Last day we talked about digital elevation model dataset, which is a raster data, and we downloaded the dataset from Open Topography website, which is SRTM 90-meter dataset. The following concepts are very much important in our hydrology analysis. First of all, the water system. So a water network system is the same basin. Water system includes river, lakes, swamps, and okay, some a water network system is the same basin. A water system includes rivers, lakes, swamps, reservoirs, etc. And the second one is the basin. So basin actually is an area that receives water from lands. And this area of water system is called basin or catchment. In our presentation, you can see that the basin outlet is there, and water system, the catchment areas are this total area, and this whole basin consists of some sub basin. Actually, the sub basin boundary, you can see that this one is a sub basin, this one is a sub basin, and also this. So, and there have some sink point also, that the uh, sink point is actually the uh, point where all of the waters are accumulated. So the sub basin actually, an entire basin is composed of several sub basin actually. So we can differentiate, for example, in our Bangladesh. In Bangladesh, there have different basin like Sylhet Basin or the Sunamganj Basin. Sylhet Basin is actually the largest basin of Bangladesh, and it consists of different sub basins. And the next one of basic concepts in hydrology analysis is watershed. So the watershed is usually determined by mountains or highlands. Okay, and the catchment point is actually like the end of a river that pours waters to a larger area. We will demonstrate detail this in our next slides. Okay, so as our today's demonstration is totally based on practical works, we will demonstrate such things using both theoretical knowledges to enrich our net knowledge, and to fulfill our demand of desire. And also we'll show the detailed demonstration of such processes. So for today, we will use both SuperMap iDesktop. I'm closing all of the things. Okay. I'm just closing the workspace. No. Yep. This is our SuperMap iDesktop X, and we will also use the SuperMap iDesktop. For example, I'm showing you the interface of SuperMap iDesktop 10i. This is SuperMap iDesktop 10i, and this is the SuperMap iDesktop X. You can use both of the software for such demonstration or processing. The functionalities are same, and you will get same anti-trace trial license after you install the software in your PC. Okay. So it's opening, and also I'm again showing you this is the interface of SuperMap iDesktop, and everything is same as SuperMap iDesktop X. Okay, so I'm not doing such things for now. I'm going to supermap.com. So here you can download both SuperMap iDesktop and SuperMap iDesktop X. From here, you can see that the SuperMap iDesktop X is this for both Linux and Windows, and these are the SuperMap iDesktop 10i for both. This is for Windows version actually, and there have some other versions here. So I suggest you to install SuperMap iDesktop, this one, or SuperMap iDesktop X, this one, or you can download the bin version. This is actually the green version of SuperMap iDesktop X. You don't need to install. You just this is like a portable software. Okay, and this one also SuperMap iDesktop bin version. Okay, so if your computer or PC configuration is comparatively low or less than the other high configuration PC, then you can use such green version like bin, these two version. Okay, so I highly recommend you to install such software, and you will get 90 days trial license after installation. Okay, so let's move forward. So if you have any question in the meantime, you can ask me in the Q&A section of or you can write your question in the question section of today's training. Okay, so these are two. This one is SuperMap iDesktop 10i 2020 version, and also this one is SuperMap iDesktop X 10i 2020 version. So both are same functionalities, but this is the updated one, and we will use both of this software for today's demonstration. So first of all, we have our data set. So if I am going to my SuperMap iDesktop X, and I will just create last day we shown you that we have to create new data source under our workspace. So first of all, I would like to create a new data source for day 2 training. To create new data source, so just right click over here and select this one, new file data source. It will create a new data source for you, and we need to specify the location. I'm just making a new folder. data day 2. So this is our day 2 data source, and we will import our data sets. Like we last day we have shown you, we downloaded the dataset of Bangladesh from open topography, which is a open data tool, open data portal, to download SRTM dataset. And also we downloaded the administrative level dataset from the other website. So first of all, we will import the dataset in our data source, then we will save our workspace. So our folder is this one, that where we kept our dataset, this one actually, and we will import the dataset from here, like this one, output SRTMGL3. So first of all, I'm just right clicking over here and selecting import dataset. Here, this one you can see. So the import dataset window arrived. So we will import the digital elevation model dataset and also the boundary dataset for this digital elevation model of Bangladesh hilly region. Actually, the southeastern part of the Bangladesh is Chittagong Hill Tract, and this area is mostly hilly region of Bangladesh, consisting of different hills and high topographic region. Okay, so I'm just adding the files from this one. Day 1, this is our output GL3, and this one is our clip dataset. Open, and here you can see we have the SRTM GL3 output dataset, and we can import such dataset by using such dataset type like image type or raster type. For our today's demonstration, we will import such dataset as raster data type, as we want to process such dataset to prepare some catchments, showing how to delineate the watershed, and also the map the stream order of this area, and also some other mapping processes. So we will import such dataset as raster dataset, and this one I am naming like SRTM DEM. So I just renamed this one as SRTM DEM, digital elevation model data. Okay, and this one is our admin boundary. Okay, so I'm just rename this to dataset, and I will import such dataset. So our two different dataset, one is our digital elevation model data, and another one is our administrative boundary data. Both have downloaded here. Okay, so if I just open this admin boundary in a new map, I can open such boundary right clicking over, like adding it to a new map, and also I can just select this one and drag it over here. The admin boundary will open in a new map window, and you can see whenever you open any shapefile or any data or any raster data set in a map, the map window will appear, and there have some operations tool sets to uh, to, to do with such map window. There you can swipe the map, there have the map operation, you can clip the map, you can measure the distance, area, or angle, such things by using these tool sets. You can import or add dataset from your databases or from any data sources. Okay, And you can see the properties both for map properties and also for the layer properties from here. Okay, and this one is our SRTM DM data. So what I'm doing, I'm just opening the same dataset in the same. Okay, this is our digital elevation model dataset, and this one is our admin level dataset. So we will clip the digital elevation model data. If I just change the style of the layer, so I just right click over here and select layer style, selecting the null value from here, and like 1. So here you can see that this one is the admin boundary, and also these are the background layer is showing that digital elevation model data of this area. Okay, this is actually the Chittagong Hill Trek region of Bangladesh, and this one is one Upazila, which is admin level 4 of Bangladesh. So first of all, what will we do? We will clip our digital elevation model according to our shapefile, or this administrative boundary actually. So to do this, we will go to this map section. Here you can see that we have operation. We have this map clip function, and we will select this object, as this one is our object, and we will select the object from here and just select this object from here. The object is being selected, and right click over here. So after right clicking that, you have one new window that here you can see that we have both of the layer from here. One is admin boundary and another is digital elevation model here. So we are only interested to clip the digital elevation model according to this object. So I am removing admin boundary from here, and I'm just, and this dataset will saved under this dataset. So to do this, the target dataset will be the SRTM DEM clipped. Okay, and if I click OK, here you can see the result dataset SRTM DEM clip has been added in the dataset or data source. Actually, this one is a single dataset. So if I open this dataset to a new map, here you can see that the new map showing the clip dataset of this data. And if I just add the admin boundary in this layer also, and it's showing that the same. If I change some color from here, so here you can see that the clip dataset is showing in our map. So for now, we will save this map. So this one is SRTM clip date 2. Okay, the map saved here, and we will save the workspace. So to save our workspace from here, we can just right click over here and save our workspace, and our workspace will save in our day 2 folder. This one is our day 2. Okay, save this one. Okay, so this is the process for importing, or that I shown you earlier day, and we are going to move forward to this session. So we are here. The first process for processing to processes are to demonstrate our hydrological analysis using SuperMap, which is application of GIS in hydrology. The first step is filling the sink. Okay, so the sink is an area with lower height than its surroundings. Sink includes natural sink and also the fake sink. The natural sink appears in the alluvial plain with large area, such as glacier, karst, mining area, etc. And however, the fake sync refers to the sync generated from the error of data processing or inappropriate interpolation. And most sync in DAM data or digital elevation model data are fake syncs which affect the water direction. So you have to fill sinks before hydrology analysis. For example, if there is a fake sink in digital elevation model or dam, the water will pour into the sink instead of original direction. And this doesn't meet the practical situation actually. So first of all, I'm going to our SuperMap IDEX, and here you can see that we have spatial analysis toolsets from here. This tab actually, spatial analysis, and under this toolset there have raster analysis and also have the water hydrology analysis toolsets. So the hydrology analysis toolsets consist of different hydrological tool analysis. First of all, this one is the field sync, and we shown you the details of field sync. So we will today use such dataset. For example, this one SRTM digital elevation model clip dataset to function to process all of the functions and show you the detailed demonstration of such functionalities using SuperMap IDEX. Okay, so for now I'm going to raster analysis, going to hydrology analysis, and selecting field sync. So the field sync data field sync processing window arrived in, and here you can see we have three different options. First one is the source dataset, the second one is the sync data to be excluded, and the third one is our result dataset. Okay, so we can select the source data from different data source. For example, I only have the day 2 data source from here, and under this one we have two different digital elevation model data. First one is SRTM digital elevation model, which is the entire data set of the Chittagong Hill Trek region of Bangladesh. And the second one is SRTM DM clip data, which is the clip data that we clipped before to process our processes or to run our processes in hydrology analysis. So we will use the SRTM DM clip dataset to show the demonstration for today. Okay, so the input dataset will be the day 2 data source, and the dataset is showing that we have both these two dataset, these two raster dataset, and we will only select the SRTM DEM clipped. So you can select the sync data to be excluded, but this is the optional data, but I'm not doing such things for now for time being. Just selecting the result, and this one is the result field sync, and you can also make a different data source under same workspace to gather all of your results. Okay, so for example, if I want to create a new data source under day 2 data workspace day 2, so I'm just right clicking over here and selecting a new file data source, and if I just make that results day 2. Okay, save this one. This is our new data source to store all of our results from these functionalities or processes. And I'm here again going to the raster analysis, the hydrology analysis, and selecting field sync. And from here we will select the result dataset. So the input is day 2 data source, and the input dataset will be the SRTM DM clipped, and the result dataset is day 2 result field sync. Okay, so for now I'm just running this one So the process run, and here you can see the result will sync. And if I just open this data to a new map, it's showing that the data set is refined, and there nothing to be excluded from here. Okay, so if I want to again to exclude such areas, and if I select the admin boundary from here, pressing 1, and open this data to a new map, and this one will be excluded from here. Okay, so we don't need this result again. I'm just deleting such data set and opening to a new map, and I will clip this data set again. This one, going to map section, operation, map clip, object, select this object, right click over here, and delete such things. Okay, fill sync, clipped. Okay, so this one will be our final fill sync data. If I just remove the previous data from our layer manager, this is the fill sync data set of our this fill sync data, or this SRTM DEM clip data set. Okay, so the fill sync covers the lower height than its surrounding, and the fill syncs affect the further processes like flow calculation, or like calculating flow direction, flow accumulation, watershed, basin, or pore points. And this actually ultimately impact the final result for like river classification or water system or stream order actually. So then the next process we will conduct the calculating flow direction actually. So the flow direction, for example, the hydrological direction of the flow, it's like actually the calculating flow is one of the key steps in hydrological analysis. Hydrological analysis functions based on the flow grid, such as the cumulative water, the flow length, and watershed. So in SuperMap, center grid has 8 neighboring grid with values. For example, it values 1, 2, 4, 8, 14, 32, 64, and 128, which indicates total 8 direction, that is east, southeast, south, southwest, west, northwest, north, and northeast. The flow direction for a center grid is determined by its value. For example, the value of flow direction is 16. It means that the water runs to west. So you have to maintain, or you have to keep in mind that the number of flow direction showing the direction of this water, for example here the direction 16 means the water runs to west. Okay, if we go forward, so how to process the water in boundaries actually, as the grid cells in boundaries have less than the 8 neighboring grid cells, and so the flow direction of those grid cells can be treated as following or flowing outside, or can be treated as no value for flow direction. So here you can see that the image showing the flow at edge, from this edge flow like 64, 64, 128, and these are the 1, 2, these are 4, 8, and these are 16, and the next one is like don't force flow at edge, and here you can see that the edge values are showing no value. So it's clear that the if the flow direction of this grid cells can be treated as flowing outside, or it can be treated as no value. So the flow direction actually is a gradient grid for elevation changes. The flow direction is determined by the maximum gradient. So if we want to calculate the elevation gradient, here you can see the center elevation. The formula is very simple, that elevation gradient is equal to center elevation minus neighboring elevation and divided by distance. So if we uh, subtract the neighboring elevation from the center elevation, then we divide the result by distance, then we get the elevation gradient from the calculation. So the flow direction will be determined by the maximum gradient. And the flow direction of flat areas, for example, as we think that the plain land, the flat areas are the areas that are the elevation gradient is 0, and the application will raise that the flat area to make each point have the flow direction. The application performs the raising operation according to the elevation around the flat area, calculates the most steep slope, and take the slope direction as flow direction. So if we go to our yes, we will see the result. So if we go to our software, here we'll go again the spatial analysis, the raster analysis, the hydrology analysis, and here you can see we have such flow direction toolsets. So if I open this, so here you can see we need to input the result field sync clip dataset here, and the result dataset will be the result direction grid and direction drop grid from here. So the result will be this two dataset. This will be flow direction grid and the drop grid dataset. And we can force boundary raster or outflow or get the changing elevation gradient. These are the optional toolsets for you. You can check mark this or uncheck these toolsets. And here you can select the result bounds. So for now, I am selecting like yes, specific dataset bound. For example, that the result field sync clip, this one. And effective analysis area, you can select here. The effective analysis area is admin boundary. And you can select the default cell size, the minimum resolution of all dataset. Okay. So this one is the environment setting for calculating flow direction. You can set all of the environment for every calculation or every processes. So the projection parameters have been set over here, and if I run this analysis, you can see that we have two output. First one is result direction grid. If I open this to a new map, here you can see the result output, and if I open such a drop grid here, this one is the drop grid window. So here, this is the actual results that the showing flow direction of the raster dataset. This one actually one raster data of our if I close such map, this one, and this is the field sync result, and this is the flow direction result of the field sync. So it's showing that the raster values of every pixel has different flow direction, and these are showing like aspect maps in our digital elevation model. Okay, so this is the result for the flow direction. And if we go forward that we'll get this. For example, if we have such flat areas and we have this flow directional surface in our software. Okay, so here you can see the flow direction window. Okay, so that we will move forward. Next ones. So the flow length calculation is very important part of our hydrological analysis. It's actually used to calculate the length between each cell and the outlet or source along the flow path actually. So the flow length is the result. There will be a grid data set, and flow length is commonly used for flood calculation. As the hydrology have a great impact on flooding, or flood analysis greatly depends on the hydrological analysis or tool sets or processing of the application of GIS. We calculate all of the things, and the calculation of flow length is very much important here. So the flow length is commonly used for flood calculation, and water flows can be affected by factors such as slope, soil moisture, and vegetation cover. Where dataset is needed to model these factors actually. So if you get any weight dataset, for example, the soil moisture, slope dataset, vegetation cover, and you set all of the weights there, for example, 1 to 100 or 1 to 10 weight, and you calculate the percentages of the effect of these such factors, and this will show you the water flows by your region, and the operations will get the flow length calculation, and it helps you to identify the flood calculation in your study area. And the flow length must be based on flow direction actually, as we calculated the flow direction right now. And before calculating the flow length, you need to set direction actually. So there may be two direction. One is downstream and the other is upstream of flow length. So the downstream flow length calculate the length of the flow path between each cell and its corresponding outlets on the edge of the raster. And upstream flow length calculate the length of the longest flow path between each cell and its surround source cell on the watershed boundary. So the main difference between these two, that the downstream calculates the length of the flow path between the each cell and its corresponding outlet on the edge of the river actually. And on the other hand, the upstream flow length calculates the length of the longest path between each cell and its source on the watershed boundary only. So here you can see these two image. They are showing the upstream and downstream flow length. So the upstream flow length, this one showing the path between each cell and source cells on the watershed boundary. These are the watershed boundary cells. But the downstream flow length is showing the path between each cell and its corresponding outlet edge of the raster. So here you can see the downstream flow length and the upstream flow length. Okay, so we will go forward to calculate the flow length in our SuperMap IDEX X. So if I just go to spatial analysis, raster analysis, hydrology analysis, and see the calculate flow length. And here you can set the weight data. I'm not getting to set such data set. And this one is our result data sets. We will select the result direction grid from here. And you can set the calculation, like you can set go up downstream or go upstream from here. Here you can see it, the parameter, and I already explained the downstream and upstream parameter calculation here. So here you can see, if we select the downstream, we can get the length of the flow path between each cell and its corresponding outlet on the edge of the raster, or you can set the upstream to see the calculation of the length of the longest flow path between each cells and its source cells on the watershed boundary. So for now, I will only select the downstream, and the result will be the result underscore flow length. So if I run this result or model, here you can see that we will get the result flow length data in our day 2 dataset result. If I want to open such data in our new map, so here you can see the flow length layer of our raster layer showing here, and the result is showing such like this. Okay, and for now I'm moving forward. The calculation of flow length, actually this is for a weight distance. If we get a weight distance data, a weight data set should be specified for calculating the flow length. In flow length analysis, flow direction data provides the flow direction of streams. This dataset can be created through flow direction analysis, and weight dataset defines the impedance of each cells in the raster actually. And the results are here. Okay, so now we'll go forward for our next tool sets for flow accumulation using SuperMap X. So what is flow accumulation actually? The flow accumulation is based on the flow direction. You can use weight data to calculate the weight flow accumulation, and also the idea of calculating flow accumulation. For example, suppose that every cell has one accumulation, and based on flow direction, the flow accumulation for each or every cell can be calculated, which is shown as before, or which is shown as below. For example, here you can see the flow direction data, and this one is the flow accumulation data. And flow accumulation is doing based on this flow direction. And also, if you have the weight data to calculate the weight flow of accumulation, so suppose that every cell has one accumulation. For example, this one accumulation. Based on flow direction, the flow accumulation of every cell can be calculated, which is shown as below. So, for example, these tool sets and these tool sets. And the result will show the total accumulation for every cell. Each cell will be each cell or each value is determined by all upstream cell except current cell itself. In practical operations or application, the amount of water for each cell is not necessarily the same. It needs to specify the way to obtain cumulative sinks actually. And after the use of the weight, each cell of the water is no longer a unit, but multiplied by the weight. And the third, the result helps us identify the valley and the watershed. If the value of the accumulation is high, this place is valley. If the value is 0, this place is watershed. So please keep in mind that the result helps us to identify the valley and the watershed. So which one will be the valley? The valley will be this portion if the value of the accumulation is high. This place is valley. And if the value is 0, this place will be a watershed. So the flow accumulation offers reference for calculating areas, perimeter, drainage density, etc. So if we go to process our flow accumulation in SuperMap iDesktop, we can go to spatial analysis, raster analysis, hydrology analysis, This is our calculate flow accumulation. And for here, we need to specify the data source, and this will be our result direction grid. And we can set the weight data, but I'm not uh, for now. I'm just keeping this as default, not no any weight data. Okay, so I'm just selecting this result data, and this one will be the result flow accumulation. I'm just running the model. Here you can see we got the result flow accumulation from here. If I open this in a new map, so here you can see this is the flow accumulated flow of this result of this direction grid. So this is our direction grid, and this is our accumulated flow. This is actually the downward flow of water. Okay, so if you have any question regarding such tool sets or such processing, please make sure you can ask me in this Q&A section of today's training. You can ask me in the Q&A section and write your question in the Q&A box. So we will take a 5-minute break for now. We will start again after 5 minutes. Okay, thank you everyone. Hello. Okay, thank you everyone. We are starting again our 10-minute break. Okay, it's all clear. So I'm starting again, and if you have any question regarding anything, you can ask me in the Q&A section. You can ask me here. We will try my best to answer in this time. So moving forward, this one was our flow accumulation result, and where we can see if we there are the fixed values, if there are anything, for example, if the value of the accumulation is high, the place is valley, and if the value is 0, this place is actually watershed. So flow accumulation offers references for calculating area or perimeter or the drainage density. So for now, we'll go forward to see our next part for calculating the pour points. So the pour points is based on both flow direction and flow accumulation actually. The pour point is at the boundary of the river, that usually the lowest point at the boundary. The pour point must have higher cumulative waters. According to these features actually, the pour point can be extracted based on the flow direction and flow accumulation. The places having register value bigger than the threshold you specified will be considered as pour points. Therefore, the threshold is critical to determine the pour point number, location, and size of the sub-basin and range. So for a reasonable threshold, you need to consider the basin within soil characteristics, slope characteristics, climate condition, and other factors. The threshold can be distinguished based on flow direction and pour points. So if I go to IDEX X and going to spatial analysis, raster analysis, hydrology analysis, this one is the calculating pour point. Okay. Here, the threshold, you can see that you can select the threshold for this flow direction and flow accumulation grid, and this one is actually the threshold for calculating the pour point. And this is the default value, and you can set the pour point threshold from here. And also I'm just running tools, and if we see that the pour points, these are the points. For example, these points, this is the pour points, and there have some other pour points. Here you can see these are the pour points for the flow accumulation and for flow direction tool sets. This one. Okay. So this is that. The next one we will go forward for like watershed segmentation. So watershed segmentation, as we all know, that the watershed segmentation is actually it is the process to divide a basin into a number of sub basin. So if I have a large area which is by a larger basin actually, and if I want to segment the basins in different sub basin, the process is the watershed segmentation. And by calculating, you can get a larger basin, but in actual you may need some smaller sub basin divided from the larger basin for your study area. So first determine the pour points for each sub basin. Those pour points can be located in boundary or internals actually. So if I go to the section for watershed segmentation in our SuperMap IDEX.x, going to spatial analysis, raster analysis, hydrology analysis, watershed segmentation, this one. And here you need to select some for like result pour points dataset from here, this one, and we need to select the result grid or direction grid dataset from your earlier process. And here you can set the expression if you have the parameter section. I'm not going to do this for now for time being, as we have limited time, and we have to process many more tool sets by this time. So the result will be the result watershed here, and if I run this dataset and open such watershed data to a new map, here you can see we got a huge basin, and the basins are subdivided by a number of sub basins by the process of watershed segmentation. So these are different watersheds or sub basins, and this one is our whole basin in our dataset. Okay, and every watershed showing here, like if I want to change the thematic map, or if I want to change the color from here, like if I want to go or this combine mode or stretch mode, and I can change the color from here. Here you can see I can change all of the color sets from this portion to this one. Okay, so that's all. And this is the process for the watershed segmentation in our hydrology analysis using SuperMap IDEX.x. Very much simple. Okay. The next one is our drainage basin actually. So drainage basin calculation is from the catchments, or from uses the flow direction raster, and the drainage basin refers the catchment actually. The basin calculation is to create a raster dataset for basin, and you can do this using SuperMap IDEX.x very clearly, very easily, and very quickly. So the calculation of the drainage basin is based on flow data, and each cell is assigned a unique basin. As shown below, a drainage basin shows that all the interconnected grids in the same direction basin. Here you can see, in general, all the pour points are located in the boundary. So firstly, you have to determine the pour points, and then identify the watershed, and finally determine the basin. As we previously determined the pour points from our dataset, and then we identified the watershed by using the watershed segmentation toolsets to show or to subdivide the basins into different sub basin, and now we can finally determine the basins. And if you check the force boundary cell force outside, the result will be better. So if I go to our software, so our super IDEX X, I'm going to spatial analysis, raster analysis, hydrology analysis, and here you can see we have the basin calculation. This one, calculate drainage basin. So if I select this, and here you can see that the result direction grid and result basin from here. And if I run this tool and open our result basin in a new map, and these are the basins here. So there have a number of basins in our dataset or toolset. And if I see the watershed data, these are the watersheds and these are the basin. Okay. So the river basin is, if you check the force boundary cells for outside, the result will be better. I didn't did this. And the next one is extracting the raster river. As our one of the main one of the main objective for this tourist training session is extracting the river system analysis. We can set we want to extract the river from the raster layers, and after that we will vectorize the river layer, and we'll make some maps and map some layout. Okay. So extracting raster river, that the grid water system extraction is the first step for the following water system extraction. As we know, if a cell has high accumulative water, this cell can be treated as the valley. And you can set a value, cells whose water accumulation is greater than this value will be extracted. In this case, the grid water system is calculated, and in practice, the values differ based on different valley. So you should practice more to determine this value. You should practice, you should input the threshold value more than one time to get better result of your study area. So for example, if the water accumulation is greater than 2000, the cell is treated as the catchment. And in this case, the express for grid water value expression is such expression like data source, like this is our water accumulation grid, or this will be our data set, which will be the greater than 2000, and this will be treated as the catchment. Okay. And here you can see that after calculating, if the water accumulation of the cell is greater than 2000, the cell is assigned to 1, otherwise it will be assigned to 0. That means true or false value. This is actually the binary value. And the following picture shows the grid water system extraction, which is the first one showing that the accumulation raster data, and the next one is the river system. Okay, so if we go to our extraction of raster river by using our tool sets, going to spatial analysis, raster analysis, hydrology analysis, and here this is our river system extraction toolset. This is actually the stream order, and this one is the extract river raster river system. So we will extract the raster river, which will show us that which one is not a river and which one is a river connection by using 0 and 1 value. Okay, so or it is actually true false value. So I am just selecting this here, this tool set actually, And here you can see it will be use the flow accumulation result from our raster result day to result data source. And okay, and the accumulation is here showing 1000. So you can set your result, or you can change the threshold from here. So I'm just keeping it as default, and this is the raster river. Okay, so if I will ignore the no value, you can check this, but I will ignore the no value. And if I run this calculation, and here you will get the raster river from here. So here you can see that raster river layer is showing the values. For example, if I create a thematic map, create unique values. Okay, and here if I check, like, this one is 1, and if I check like this color, here you can see there the river system extra or raster river showing here, and the other are the no data value I assigned there in I assigned before in the process window. And there will be no value. And this is the system for extraction of raster river from our raster dataset. So this is a major portion for hydrological analysis, extraction of river in our raster data. This is from our digital elevation model. Okay, so I'm moving forward. So here you can see this one was our flow accumulation, and this is our raster river. And if I go to again flow accumulation, this one was our flow accumulation layer, and this one is our raster river from this flow accumulation. And if I just copy this layer and then go to flow accumulation, and if I just paste the layer, insert copied layer, here you can see the accumulated river are showing in our, or if I just change the layer properties or visibility of the layer transparency like 60%, here you can see the accumulated layers are showing here, and the raster rivers are showing in our flow accumulated in the upper portion of our flow accumulation raster result. Okay, I think it's clear to you, but if you have any question regarding such things, you can ask me in the Q&A section. Okay, so for now I'm moving forward. Okay, and this one is the first layer, which was flow accumulation, and the second was raster river layer. Okay, so for now we'll go for river classification, which is actually the stream order. Stream order actually is a major portion for our today's training, and the river is divided into the main stream and branches, as we know. According to the amount of flow and river shape, the river can be classified. So based on grid water system, the river are numbered. The larger the number is, the higher the level the river is. So SuperMap provides two methods, including Stoller method and Shreve method of river classification. So these two methods classifies our rivers in a numeric way, and the higher the number, the larger the river is. So if I go to the detail, actually these two method, for example, Stoller stream method, stream order method, According to the top-down system, which is devised by Stroller, rivers of the first order are the outermost tributaries actually of two streams of the same order merge. The resulting stream is given a number that is one higher. That means if the number one and one, these two rivers combined, there will be a higher number, which is 2. If two rivers with different stream orders merge, the resulting stream is given the higher of the two numbers. And the second one is Shreve stream order, which is this person is also gives the Shreve system also gives the outermost tributaries at the number 1. Unlike the Stoner method, at the confluence, the two number are added together. And Shreve method or Shreve stream order is preferred in hydrodynamics actually. It sums the number of source in such catchment above a stream gauge or outflow and correlates roughly to the discharge volume and pollutes the levels. And also it shows the pollution levels. Like the Stoller method, it is dependent on the precision of source included, but less dependent on map scale. So if we go forward to show you to demonstrate the actual demonstration, there we are in our SuperMap IDEX.x. And if I go to spatial analysis, raster analysis, hydrology analysis, here you can see we have this stream order toolset. And here we have to input we have these two methods for stream order. One is Shreve method and another one is Stroller method. Okay, so you can select both of this method. One is Shreve method, another one is Stroller method. And if I select here, you have to select the river system data, which is river raster result raster river, which we calculated before. This one raster river, and we have to input the flow direction data here. The flow direction result is also imported from our result dataset, and we need to select the method which we want to or which we are interested to. So as I detailedly showed you here that we can do Stroller stream order method, or we can use the Shreve stream order. We'll use the both and we'll see the differences between these two. So first of all, I would like to select the Shreve stream order here, Shreve stream method, and I'm just renaming this as Shreve as H. Okay. And if I run this one, this is our stream order method. If I open this to a new map, here you can see that we got such result. And if I change the layer properties or set the color table from here, if I change the color table for them, for example, range map, or change the layer control from here, right click over here, select the set color table, select color from here. Okay, so here you can see this is the method for stream order Shreve method, and we will again go for the Stroller method. So to do this, I'm going to raster analysis, hydrology analysis, stream order, and for now we will select for Stroller method. And I'm just renaming as Stroller. Okay, running this result, and this result will be the as like this same, but the main difference will be the numeric order of this river. So I will show you after the vectorization of such rivers. Okay. I will show you the differences of these two. One is stroller and one is sheep method after vectorization of these two layers. Okay, so now this is the time for river vectorization, which is water system vectorization, which is to convert the grid water system to vector water system and store the river level to the attribute table. And the following picture is a dam and the vector water system. You can see here that the digital elevation model and also the vector river showing in our image. So for now, I'm going to SuperMap iDesktop and spatial analysis, raster analysis, hydrology analysis. This one, river system vectorization. Okay, if I select this tool, and here you can see the river system data is the result stream order. This one will be the shape and the result direction grid flow direction data. And here, as we are using the shape layer, stream order shape method, shape stream order method, we will set the parameter as shape method, and we will change the name as SHREB shape. Okay, and I will run the analysis. Here you can see that the shape method layer is showing here, and again I will go for the stroller method vectorization. So I will go to raster analysis again, hydrology analysis, river system vectorization, and here I will select the stroller, and then I will select stroller method from here and rename such as stroller. Okay, so I will run this analysis. Okay, here we will get two different result from these two different layer. One is stream order method and another is stroller. Okay, so if I open these two layer in a single map, right click over here, add to a new map, here you get the result that you get the same, there will be some differences. Okay, so this one is our shape method vectorization tool sets, and this one is the shape method, here you can see, and this one is the stroller. So the difference you will get that the number of river from here. And if I go to the shape method, for example, I want to create a thematic map. From this map, I'm going to select the unique value map from here, default. Okay, and this is the shape method, shape stream order. And if I select the from here like stream order, here you can see we got the result for this. View, toolbox, catalog, window, layer properties, layer style. Okay, this one. So if I change the color table from here, like for range map, if I select this one, here you will get the range map for this layer. And if I change the layer for like this one is the actual river system here. This is the using shape stream order method. And if I change, if I again want to add like this is the shape stream order method, and if I want to create a new thematic map for levels, for example, I just right click over this layer, that shape stream order line, and create a thematic map, which is level thematic map. This is unique uniform level unique map. Okay. Okay. And there will be the expression will be stream order. So here we can see that the style, I can change the style from here. That you can see that the styles, can select the level range map, level unique map. Okay, these are showing that the different stream order using like stream order 3, 4. This one is stream order 6, and this one is stream order number 1. These are the stream order 1, 1 and 2, and this one is also 1. That means these two stream order consist are combined here and made this stream order 2. This is the second order, this is the first order, and it continues to total 8 order. Here you can see total 6 order, sorry. First, second, third, fourth, 5, 6, fifth, and 6th order. And these are for the stream order method. And if I want to group them, create a group. This is the SHREP strip, and I want to move them to my group. This one, this is a stream order method, and this one is the stroller stream order method here. And if I want to make a thematic map using this stroller stream order method, I'm going to create thematic map, unique value map. Okay, and set from here stream order. Here, this is the only one stream order using the stroller method, which is the only first order. So you have to select your stream order method by your desire or varying expectation or the parameter you use in your study area. So this is the only one stream order for using the stroller method. And if I just want to create a level thematic map by using this layer, just right click over here, create thematic map, level unique map, this one. Okay, and this will be the stream order. Here you can see that everything showing here is 1. Is the first order showing 1. Also this one showing 1. This one, this is the only first order. So this is the process for river classification, where the stroller method shows that the two streams are same order, and the strip method order, which sums the order of the source encasement above the stream gauge or overflow, and it correlates roughly to the discharge volume and pollution slags. So these are two different methods of stream order classification of a river. And if I add this to a new group like this one, okay, these are the stream method and these are for stroller method. I think these two methods are clear to you, and if you have any question, you can ask me in the Q&A section. Okay, so for now we will go to our next section, that I'm just saving this dataset, save workspace, saving all of the maps. Here you can see all of these maps here. Okay, all of the datasets are here. So after river vectorization, by that we vectorized the river, and by this method, the result retains the information of river level and flow direction. So we already have shown this, and the vector river extraction calculates each river level and automatically adds a file named the stream order attribute to store the value of the resulting dataset. And for the classification method, we can see the river classification method again. And the river flow or the flow of information is stored in the result dataset called direction field, which expressed as 0 or 1, which is a binary dataset. And 0 indicates the direction of the flow of the line objects geometric or line object geometry, and 1 represents the line object geometry in the opposite direction. So the direction value field is 0. And for now, here we have another section which is connecting water system. This is an optional actually. So this is to connect the water system is based on the grid water system and flow direction. And you can choose the connection point of water system. It assigns each river in the water system as a unique value. The water system connection records the node connection information. The red point below is the intersection point between two river segmentation. Here you can see in this image, and a river segment connects two intersection points, or an intersection point and a pore point, or an intersection point and watershed point actually. So this is for example connecting water system, like in the end of the result of water system, the river segmentation should be greater than or equal to 1 actually. So for now, as we have shown all of the functionalities, we will go forward to show you our detailed demonstration for our geoprocessing toolsets. For example, SuperMap iDextra provides the detailed demonstration for analyzing the process of hydrology analysis, as like that. If I want to calculate the hydrology individually, I ran all of the tool sets individually, but they have one ready to use model. This one here you can see that this is the ready to use model that use for like these hydrology analysis tools. All of the tool sets are uh, attached to each other, that one tool will provide the output to another tool as input, and this tool sets provides all of these functionalities to calculate all of such features or processes to provide you a better result in a quick time or in a quick operations. So to do such things, or to as I show you that here you will get all of the things like field saying calculating flow direction, calculating flow length, calculating flow accumulation, drainage basin calculation, calculating pore points, reversing dataset, watershed segmentation, connecting uh, river system vectorization, stream order. So all of the things are attached to each other, and you don't need to run individual tool sets and to get your whole result. So if I want to run this tool set, and if I want to run this tool set, I will make another data source under this workspace, right? Like click over here, new file data source. This will be our result from model. Okay, this is our result data source, and we'll use this SRTM DM field sync clip, this dataset. Okay, and if I just select this field sync, double click over here, and here you can see that the parameter setting will be appear in this site. So we will select like data to result field sync clipped, if you want to use such dataset, and our output dataset will be stored in our result model, in our this data source that we created now. So, and this is done. And if I just going to GIS modeler, run this, and it will show the result from here. So we will run this in our iDesktop. And this is actually the model. We will execute this model in our SuperMap iDesktop 10i to show you the functionalities in 10i directly. But everything is all are same using SuperMap iDesktop X or SuperMap iDesktop. You can use both of these tools. So as this is another prayer time, I will take another 10 minutes of break for you. We will get back to you after 10 minutes, and I think you will enjoy the whole session. So hello everyone, we are again starting our session. Okay, now if you have any question regarding anything, you can ask me in the Q&A section. And we are again starting our today's session. So as we have shown you how to do such all of the things, now this is time for application of models. In I will input add our dataset in SuperMap iDesktop 10i. The same processes. I just want to introduce you SuperMap iDesktop 10i. So that's why now I'm switching to SuperMap iDesktop 10i, but all of the functionalities are same. Okay. So now, if you have any questions regarding anything, you can ask me in the Q&A section. And I am importing my data source, like open file data, opening my workspace, actually file workspace. So I'm going to my folder, University Day 2. This is our Day 2 data. I'm opening this data source, and here you can see our all of the data sets and maps are available here, and these are the data set. Okay, so everything here you can see, all of the things here are as same as like this. Okay, these are the same things in our SuperMap iDesktop 10i and also SuperMap iDesktop X. Okay, so for now I will open geoprocessing. We'll go to spatial analysis. Here you can see the hydrology analysis, and this is our hydrology analysis model. So here you can see that we have such functionalities. For example, field sync, flow direction, flow length, flow accumulation, 4 points, watershed segmentation, drainage basin, extracting river raster data, stream order, water system, and also connecting water system. So for example, I will just select this any of the tool, and the other side there will be the parameter tool sets, and we can select the parameters from here. Okay, so if I select the field sync, and this will be our result field sync clip. Okay, and then there will be our result will be moved forward to the result model. So why I'm using such model, actually, as we individually processed every tool sets from our raster tools or hydrological analysis tools, and I'm just selecting these tools data source from here, and this will be the filtering model. And if I just click on ready, and then if I select this one, this will be the field sync result, and this will be the result model. If I again select ready, and this will be ready, and if I select the other toolsets like this, and if I select like go upstream or go on downstream, I want to go to downstream, and if I select the result models, ready to accumulation, and there will be like result models ready 4 points, and here you can select the accumulation result from here, and selecting the output data source. Okay, the watershed, again the result model ready, drainage basin result model. Okay, extraction of river system, and there will be the output data sources. And if I want to ignore the no value cells, I can select this and click on ready, and stream order. There will be two different method, like strip method, installer method. We will use now strip method, and we'll select the data set for results. This is our result model data source. Click on ready, water system, and here again we will select the strip method, the same data source, ready, and connecting the watershed. Okay, done. So once this is completed, all of the parameters are set in our model, we can run the model from here. So here you can see one tool run from here and showing the successful result, and the result data sets are adding in our data source, this one. Okay, here you can see this is successful, all tool sets run successfully, and we got our stream to line result. And if I want to add this stream order to a new map, here you see this is our stream order result. And if I want to add the field sync grid or digital elevation data in our map, this is the result dataset. Or if I want to like field sync data, opening the field sync data in here, and remove the other data. Okay, this is our river system vectorization data set, and this can be visualized detailedly in our layout. I will show you how to make such layout, beautiful layouts in our SuperMap iDesktop. Okay, so for now, I want to make a hillshed map by using the result field sync result. To do this with the spatial analysis, here you have the surface analysis tool. Here you will get the hillshed. Okay, so this is our result field sync, and we will just select like data source, this one, result field sync hillshed. Okay, so this is the hillshed data, and I'm adding such data set to our map, current map. Here you can see, and if I just change the color table from here, as this is our hillshed, and I'm just selecting from like this one is inappropriate actually. And to go to like these tools. Okay, so here you can see 3D hillside map showing in our results. And if I turn on the field sync digital elevation model and I'm going to layer properties to change the transparency of this layer, here you will get the transparency. If I select like 60 or 40, so it's showing better result, or 50. Okay, it's showing now it's better. And if I want to create a thematic map using the stream tool line, this is a stream method stream order. And if I right click over here, select this create thematic map, unique thematic map. Okay, and here you go. You can see that we got our thematic map from here, stream order, and it's showing that a huge number of rivers from here. Okay, so I just change the, for example, like NDVI or range map, this. Okay, so this is the showing that the river systems are here. You can choose any of the color table from here. For time being, I'm not choosing such things. And also, if you want to create using like ship method from using such data set, for example, if I open the previous result here you can see that it's showing. If I remove such layers from here, like delete such layer and create thematic frame map from such this layer actually. And if I select the stream order from here, and then if I select the color table like range map, this one, and I can individually change the color of individual order. For example, if I double click here, if I select like 0.3 and change the color, for example, standard color switch to, or like theme switch to select like this one, apply, and then for color from like this one, and like this one, example 5, like this. Six. Fifth order like 7, color like this, and sixth order like 8. So here you can see that the river system showing using the strip method, and we will save this method. And this is the first order actually, like first order, second order, third order, fourth order, fifth order, sixth order. Okay, so and we can these are the orders, and what can we do? We can also create a label thematic map for such orders by right clicking over here, create thematic map, create label thematic map, unique value style, and here you see you can select the stream order from here. So it's showing that the stream order from here. So that's all to make a map, and I'm now saving this map. Save map as like map for layout. Okay, clicking OK, and we will, as in our design a layout by using this map. To make a layout, like just right click over here in layout section of your workspace manager and create a new layout. We'll select the blank template from here, and here you can change everything. Like I change orientation to portrait to horizontal, change the map size or margin, etc. But I'm not doing such things. I'm going to object operation to add our maps. So just select this map section and select rectangle, draw a rectangle to create a map here. And I'm selecting map for layout, this map, and it will add in our map. And I want to zoom the map. To do this, I'm going to layout section, focus, click on focus map and select zoom in. Okay, I'm panning this map. Okay, I think it's okay. And then you can add all of the elements in your map. For example, I can again zoom freely this map, and I can again focus this map to pan this map to add the right side. And then I can add everything like map objects. Like I can add a text map from here. Like I can add like stream order map. Okay, right click here and you can change the everything from here. Like stream order map, I can add a north arrow here. For example, in this portion, I can add like map scale here. There you can see that you can customize everything here. You have the customization tools. Here you can right click and go to properties to customize all of the things. And also I can add the legend from here. If I just take it and I click over here and go to properties to see the legend properties, and I'm going to set column like 1, and I'm zooming in. And if I go to like I just want to okay, these are showing the orders like first order, second order, third order. So you can create such maps, beautiful maps in design by your own. You can select everything. You can create group for your map. Okay, so and then what can you do? You can save the layout, like layout for print, and all of the things saved under your workspace. You need to just save the workspace, but the workspace will automatically save all of the things for you. Okay, and then what can you do? You can export this map from your layout section like you can directly export to a picture or print your map from it. For now, I'm just printing this map. So this is our day 2 data, or like this is our sample map. I printed such map. Okay, if I go to my folder, so the map already opened in my window. So here you can see we have such maps, our stream order map. Okay, by using our analysis tool sets. So this is the portion for your map making option and map designing, and you can save everything in your here. You can save your workspace. You can export your dataset as I shown before. You can open any of the map from your data source like file manager from by using both iDesktop 10i and also using iDesktop X here. Okay, and for now, I will show you another 3D hydrology analysis, which is flood simulation in our SuperMap iDesktop. I'm going to close everything, and I'm going to open a new dataset in 3D. For example, this is our real-scene clip. I'm adding to a new spherical scene. I'm going to add this as a terrain and also an image. Okay. So here you can see that this is our real-scene clip result. If I go to jump to the layer, this is our 3D terrain data of our digital elevation model. So here we will get the 3D analysis toolsets from here. From here, we will, as we are focusing on hydrology analysis, we will focus on the flooding analysis for now. This is the most used part for the 3D visualization of flooding of any area by using digital elevation model. So SuperMap has the ability to do such things. So for now, I am just showing you how to do such things. So this is our flooding analysis. In 3D scene, dynamically it simulates the flood process that the water level actually that the water level reaches its maximum elevation from minimum elevation in a region by a given time. Okay, so if I select this flooding analysis and 3D spatial analysis, as this is the flooding analysis, and you have to select the region in which region you want to show the flooding or flood simulation. So I'm just selecting this add button, and I will draw a region, for example, this region. Okay, if you want to complete, just right click over here, and here you can see the flooding already started here. It's too much interactive, and you can set all of the parameters from here. For example, you can set the maximum altitude. This is your current altitude. The maximum altitude and minimum altitude you can select. You can select the time and also the speed from here. So if I select the loop from here and again play such things, here you can see the flooding showing that the for the minimum elevation to maximum elevation flood in this time frame, and it will select the loop for here. So this is so much interactive actually. Okay, this is the portion for the flooding analysis, and there have other like slope and aspect analysis, isoline analysis for this such digital elevation model analysis in 3D analysis available in SuperMap iDesktop. Okay, so our total part was this, and I hope you enjoyed all of the sessions. And for now, I will go to the Q&A section. And if I go to the Q&A section, as before, everything, most of the questions were like, how will you get the tutorial, or how will you get the data set, the training materials, the video recordings. Everything you will get via email very soon, and you have you just please email us via ubaidur@gmail.com or zarin@supermap.com, and hope you will get all of the materials very soon via email, and every detailed thing will be uploaded to online with you to share with you. And there have some question. Okay, so which module of SuperMap can you calculate slope area, not for base area? I want to calculate sloped area or hilly areas. Yes, you can use the raster analysis of SuperMap. Like for example, if I go to spatial analysis, there you have the surface analysis. Here you will get the terrain calculation toolsets to do such things. Okay. Okay, I'm going again. Okay. Yes, can we make our own model using model builder? Yes, there have some geoprocessing tools like this. You can create your new model, own model by using such things. They have all capabilities. Okay, trial version. Yeah, when you use it, we can get the map or export from this. Yeah, you can get everything in your trial version. In which format the vector features in SuperMap? You can get any dataset in any format in SuperMap, like shapefile or get file or other vector data source files. You can import anything in SuperMap. If I add Google Map background, it's Chinese. How can I change? Actually, SuperMap now using the Google Map for Chinese version. But if you once registered for the software, you will get the full version. But the next updates, you will get the English version also. So this is not actually the true version. The SuperMap iDesktop is the stable version, and the SuperMap iDesktop X is the most updated version of SuperMap product family. So you can use both, and also you can use any one. Yep. Yeah, you will get all of the certificates via email very soon. Can we provide a flat level? What is the native file format of vector file? You can use like shapefile, or you can use KML file. Actually, this is used in the SuperMap workspace, and also the data source. And data source combine all of the data sets, and data sets can be in different formats. There have no limitation, there have no boundaries. And that's all for today. There have no questions, I said. Yes, we will share you all of the things via email, and also you will get all the recordings in SuperMap YouTube channel. You will get everything in our supermap.com website. You will get everything SuperMap GIS YouTube channel. You can follow the SuperMap Facebook page. You can follow SuperMap Twitter page, and also SuperMap GIS Instagram. And you can reach us via bees@supermap.com or ovido@supermap@gmail.com or jarin@supermap.com. And thank you everyone for joining this 2-day session of GIS application on hydrology. Hope we will arrange many more sessions in the coming days. So stay safe and be prepared. And thank you again for joining such training session.